Hello everyone, my name is Umar. Welcome back to the channel. I hope you guys are doing absolutely fine. So in this video, we are going to talk about not pizzas, we are going to talk about subnetting. But let's start with the pizza. Now what we see in this image is a beautiful cheese pizza. Now what is important in this pizza? If you see this base, okay, imagine this pizza without this base. What are we left with? We are left with cheese, we are left with some veggies and olives and everything. But do you really want to have that kind of pizza which does not have a base? No, no one wants to have it. It is not a pizza anymore. Subnetting in networking is just like that. Subnetting in networking is just like your pizza base. So I can say this is subnetting. Okay, I'm not really drawing things over here. So just giving you a message that subnetting is as important as a base of a pizza. If you don't have the base correct, even if you know everything in networking, you know about all the routing protocols, but if you cannot subnet, if you cannot give the proper IP addresses, your networking knowledge is not that useful. So well, let's get started with our video. So now what is subnetting? So I have a beautiful image setup over here. So subnetting is breaking down of classful networks into smaller classless networks. And why do we do that? We do that because we want to utilize our IPv4 addresses efficiently. We don't have so many IP addresses that we can, support the existing networking equipments, and hence we are moving on to IPv6. But we didn't have it even when they were formed. Like if you would just keep around giving IP addresses and wasting them, that would not have been sufficient. Even like say 5 to 10 years back from now. Now, if you talk about classes of IP addresses, so I all assume that you have a background of what classes exist in IPv4 and how they are categorized. So in class A, we have 3 host octets and 1 network octet. In class B, we have 2 host octets and 2 network octets. And in class C, we have 1 host octet and 3 network octets. I'll just take you down to the PPT there, but for now, just I assume that you know this. Now, if you see what I have written over there, now let's say we have a beautiful example to explain why do we need subnetting. So if you see over here, read the example. So company needs 20 IP addresses. If they get a class C network, because obviously that's the only choice they can have, let's say they get an address of 20.200.1.1.0/24, and they need how many IP addresses? They need only 20 IP addresses. So a class C has a capacity of 254 hosts per network. They need only 20. They will end up wasting 234 IP addresses. Like this, I can talk about many examples where we keep on wasting huge chunks of IP addresses, and that won't be really affordable. So what we do is we do subnetting. Now subnetting, I have already talked about the definition of what subnetting is. And today I'm going to teach you about subnetting in 5 simple steps. You don't need to remember any tables. You don't need to memorize anything. You just have to have your basic math skills good. Okay. This table, I'll come to this table later, but this is nothing but a very simple table wherein I've just written powers of 2. So 2 raised to 0, then 2 raised to 1, 2 raised to 2, and so on. So it keeps on going, and I have done it till 2 to the power 16. I mean, that's simple. You just have to double it. So 1, 2, 4, 8, 16, 32, and so on. So let's clear the screen and get back to our PPT, which we have right over there. In the PPT, I'll be explaining you about subnetting by example, and we'll be solving a few examples over there as well. So let's put this to slideshow. Okay. Now, subnetting, a process of breaking down. So I've already explained the definition. I have written down class A, class B, and class C address breakdown over here. So how class A is written, it has 1 network octet and 3 host octets. The default subnet mask. Now, what is the subnet mask? In networking, when I talk about the subnet mask, I am just saying how many network bits do I have and how many host bits do I have. One thing over here, your network bits are your fixed bits. You cannot change it. I mean, if I just want to say that I belong to this network, so there can be like many hosts belonging to the same network. So the network remains constant and they have their host within that. So default subnet mask specifies that how many network bits are there and how many host bits are there. Networks are represented by 1 and hosts are represented by 0. You cannot change the network octet, but you can change the host octet from a 0 to 1. So you can have those many combinations. So looking at this particular class A, you can have 2 raised to 24 combinations. Now see why we talk about 2 raised to 24 or 2 raised to 16, because these zeros and ones, these are the only two states which are available for us, right? So if I just take you back over here, so this is one state and this is another state. So if I have 2 bits, how many combinations do I have? I have 0 0, I have 0 1, I have 1 0 and 1 1. That means I have 4 combinations. And if you say this will be 2 raised to 2 combinations, right? So if I have 24 bits like this, that means I have what? 2 raised to 24 combinations, right? So let me just clear this and get back to the slide over there. Okay, and yes, so in class B I have 2 network octets. That means I have 16 bits reserved for networks and 16 bits for hosts. If I start changing the host bits, so how many combinations I end up with? I end up with 2 raised to 16 combinations. And class C, again I have 2 raised to 8 combinations, so that is 2 raised to 8 hosts per network. The subnet mask is written, which tells you how many network bits are there and how many host bits are there. I have written down the decimal value of the subnet mask. So it's 255.000 for class A, 255.255.0.0 for class B, and 255, 255, 255 and 0 for class C. Below that, I have also written the prefix value. The prefix value is nothing but the total number of network bits I have in my subnet mask. So in class A, if you see, I have 8 bits for my network. So that's the prefix value 8. Class B has 16 network bits, so prefix value is 16. And class C has 24 network bits, so the prefix value is 24. So with that said, let's move on to subnetting. So we'll understand those 5 rules step by step. So it's a very step by step process. So the first rule says identify the requirement and number of bits required in binary to represent it. Second is write the old subnet mask and the new subnet mask. Subnet mask tells the number of host bits and the network bits. So again, just remember this, the network bits are represented by 1 and the host bits are represented by 0. Once you do that, you get a block size and you break the network. You write the new network and then you verify whatever you have done. This might seem a bit complicated, but let's solve by example so we can understand much better. Now, the example here is simple. We have an address 200.1.1.0/24. It belongs to class C. You can check the IPv4 table over there. Now, a company wants to buy an address space only for 20 hosts in their company. Now, as I said, if I give them the whole network, they will utilize 20 addresses and they will waste 234 addresses, and we cannot do that. Now, just to illustrate this, in a very simple way, I would frame it like this. You go to a grocery shop and you want to buy, say, 250 grams of something, and the guy in the shop has like a 1 kg chunk. He doesn't tell you that you can get that, you take that 1 kg chunk and then you waste 750 grams and then you use the 250 grams which you want. He tells you that listen, I have weights and I can break this down into small pieces, so that today if you want to buy 250 grams, someone else also might be needing it, so I can sell this to someone else as well. Similarly, subnetting also, I will sell you what you need and I still have a lot of addresses left which I can sell it to someone who needs it in the same manner or in a different manner. So no, that all depends on how the requirements come in and so on. But in today's session, we are just going to talk about fixed length subnetting. In my next video, I'll be telling about variable length subnetting. So for now, let's concentrate on fixed length subnetting. That means whenever we calculate one block size, we end up breaking the networks into equal parts. We don't break it into variable parts. Okay. So now the first rule says identify the requirement and number of bits required in binary to represent it. So we have the requirement as 20 hosts. Now 20 hosts, if I convert it into bits, that turns out to be 5 bits. Now you can do that online using a calculator. If your mathematics skills are good, you can just do it on paper. But I'll just give you a very, very simple trick on how to find out. Now let's say what my requirement was. My requirement was 20. Okay, so I'll just get this pen over here. Okay, so my requirement is 20. Just find out where does 20 come. 20 will be somewhere between 16 and 32. So here we have 20. All the bits above that will be required to represent 20. So how many bits do I have? I have 5 bits which will be needed to represent 20. With that, I can find out for any number. Let's say if someone tells me I want to find out for 1000, so I'll just, I'll 5,000. So I'll just put 5,000 over here. And how many bits are there? I'll just calculate the total number of bits. So 5,000 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's say 5,000 could be 13 bits. So it's a very simple trick to do that. Just have to remember this table, and it's not a very complicated table as such. Like, you can just write it down somewhere in your book or something like that, and then you can easily use this to do a lot of things in calculating it, how many bits are required, and so on. I'll just clear this and I'll get back to my slides over there. Okay, so 20 requires 5 host bits. The second step is to write down the old subnet mask and the new subnet mask. Now someone might just tell me, like, where do I get the old subnet mask? It's in front of you. Now when I have written down the address 200.1.1.0/24, that 24 specifies how many network bits are there. That's the prefix value. So straight away I know that there are 24 bits which are belonging to my networks and I cannot change them. So the old subnet, I just write down 24 ones, and that's what we have done. In the old subnet, I have just written down 24 ones and I have written down 8 zeros, because IPv4 is 32 bits and I have to fill all those 32 bits. So either it will be a 1 or it will be a 0. We don't have any other numbers apart from that. So I'll just write down the old subnet. I'll find out the decimal value. I'll just convert that binary to decimal. So 255, 255, 255.0. Now I have to write my new subnet. In the new subnet, I will first see that how many host bits are there in my old subnet. I have 8 host bits, and my requirement says that we just require 5 host bits. And you start writing the host from the extreme right. So from the extreme right, if I start writing the host, that's 5 zeros, and the remaining 3, what do I do with them? I don't really need them as host. So the other option is to make them as networks. So I'll just write down 3 ones. The first 24 will be as it is, because that's what is given to me in the example. So I'll just write down the first 24 bits as it is. These are the network bits. I cannot change them. The last octet, it had 8 host bits, but now I only require 5 bits. The remaining 3 bits, I can give it to networks. So this is the second step. Very simple one. Okay. Rule 3, break the network. Now that's what you want to do. Subnetting was, in the definition, the first word was breaking the network. Now, how to break the network? Now, obviously, if you want to break something and you want to give it a form or something like that, you need to know the size. Okay, fine. If I have to break this, so in what size do I break it? What is the measurement I take? So here, the measurement is the block size. So the block size is calculated by the octet in which the subnetting was done. Now, what is subnetting? The subnetting, we can say where the transition happened. The transition from 1 to 0s or from 0s to 1. So in our case, the last octet, we have 3 ones and we have 5 zeros. And that is where the change happened. We changed from 1 to a 0, or you can say from 0 to a 1. It's one and the same thing. So in the last octet, we see 3 network bits and 5 host bits. Yeah, that's true. We see that. Now, look at the point where the transition happened. So if I just take you back to my whiteboard, I'll just write down the last octet. Okay, so I'll just write down 1, 2, 3, 4, 5, 6, 7, 8. Now, where did the transition happen? The transition happened over here, and this 1 is important. What is the value of this 1? What does it represent? The face value. Now, how many bits we have? We have 1, 2, 3, 4, 5, 6, 7, 8. And in networking, if I just have to convert this into decimal, and I have to write it down, so I'll be writing it as 2 raised to 0, 2 raised to 1. So this will be 2 raised to 2, 2 raised to 3, 4. This will be 5. This will be 6, and this will be 7. Now, what is this value? 2 raised to 5. This is 32. So here I get my block size. The face value of this number is my block size. And if you just have to convert it into decimal, so you just have to see how many bits are on. I mean, it's simple. So how many bits are on? We have 3 bits on. So 2 raised to 7 plus 2 raised to 6 plus 2 raised to 5. That will be 128 plus 64 plus 32. And that comes down to 224. So that is the subnet mask which we have calculated in the last slide. The second step where we calculate the old subnet and the new subnet mask. Right. So I have a size of 32 which I have derived from this particular octet. Now I have a size. Now what I have to do? I have to break this network. So I'll just clear this out and I'll get back to my slides over there wherein I have to clear the network. Okay. So okay, this and this also. Yes. Let's get back over here. Okay. So here, in the last octet, we see 3 network bits and 5 host bits. The face value of the last network bit. So that one, like if you start from the host side, you will be seeing the first one. If you start from the network side, that will be the last one. That is the block size. So 2 raised to 5, that is 32. So our block size is 32. Now the next step is to write down your new networks. You have to break and write your new networks. Now in subnetting, you have to remember one simple rule. You will break the network in the octet where you found the block size. In our example, we found the block size in the last octet. So we'll start breaking it from there. So the first network you see is written as 200.1.1.0. So always it's going to start from 200.1.1.0 because that's what we were given. We have an address of 200.1.1.0. So starting from 0. Now the next network will be 200.1.1.32 because that is our block size. So 0 plus 32 makes it 32. Then 32 plus 32, 64. 64 plus 32, 96. 96 plus 32, 128. And you continue going down. Till where? Till the point of time where you don't exhaust the entire class. Now if you see, if the network starts from 200.1.1.32, the previous network will end where? It will end at 200.1.1.31. Similarly, if it starts from 64, the previous one will end at 63. If it starts from 96, the previous one will end at 95. And if you go down, you reach a point wherein you start from 200.1.1.224 and you end at 200.1.1.255. Now, can I do it after that? No, because there is no number as 256 in your IP addresses. If I try to make it 256, it becomes a 0 and it adds 1 to the next octet. That becomes 200.1.2.0 and that's not what we want. Just to show you that as well. So if I just have, let's say if I have 200.1.1.255 and if I just add plus 1 over here, okay, I'm just adding plus 1. So this will become what? This will become a 0 because it cannot become 256 and there will be a carry 1 over here. This will become 2, this will become 1 and this will become 200. So I don't have the permission to change anything in 200.1.2.0 because that's a new network altogether. So I'll stop when I reach the last address in a particular network. If I see that I'm moving on to another network, I will stop there as it is because that's not what I want to do. Okay. So now coming back to our slides. Okay. So now what I have subnetted the entire network and I have reached the end. So I have ended up with some networks which have some range. Your first address is always known as a network identifier that will identify your network. The last address will always be your broadcast address and the range which you see in between, that is your usable range. So if we just talk about the first network 200.1.1.0 till 200.1.1.31. So the first and the last IP addresses I cannot use. So what is available for me to use? From 200.1.1.1 to 200.1.1.30. I can assign these addresses to my host. Now, host could be my PC, my printer, my laptop, my mobile phone, and anything and everything which requires an IP address. And now if I write my new networks, I'll just write down them as 200.1.1.0.32.64 and so on. And I have written a number /27. Now what is 27? Now if you go back to your new subnet, the new subnet mask, you see how many ones have we written over there. So the new subnet mask, the second last line, you see there are 8 ones plus 8 ones plus 8 ones plus 3. So 8 plus 8 plus 8 plus 3, that makes it 27. In the old subnet, we had how many ones? We had 24 ones and the network was represented as 200.1.1.0/24. I told you that 24 represents nothing but the number of network bits. Now, how many network bits you have in the new subnet? You have 27 network bits, and that's what we write. So in the above representation, /27 is known as the prefix value, which is calculated by counting the number of network bits in the subnet mask. So well, this is my subnetting. I have done subnetting. Now my last step is to verify, like, did I do it as per the requirement or did I miss anything over here? So the rule 5 takes to verify, and we have two simple formulas. The how many networks we made and how many hosts per network we ended up with. Now here, the first 3 octets, they were fixed. I have mentioned that they were fixed a lot of times. So we are not going to concentrate on them while we are doing the verification. We are just going to concentrate on the last octet. In the last octet, what do we have? Our last octet looks something like this: 111 0 0 0 0 0. 3 ones and 5 zeros. So 3 ones, now 2 raised to 3, just calculate how many ones you have. You have 3 ones, so 2 raised to 3, that will be 8 networks, and 5 zeros, so 2 raised to 5, that would be 32. But if you see, when you're writing the networks, we do not use the first and the last IP address, so we have to do a -2. The number of networks is 2 power the number of network bits, that is 2 raised to 3, that's equal to 8 networks, and number of hosts per network will be 2 raised to power 5 minus 2, that would be 30 hosts per network, because we had 5 host bits and the first and the last address we cannot use. So this was a very simple example of how we do subnetting. Now, what we will do is, we will just take another example. Let's say we'll take some example from class B and we'll try to solve it. So what we will do is, we will just delete everything. I'll just give the subnetting steps over there, and I'll delete all the definitions and everything, so that we have some space over here to do things. Okay, so we will delete this, delete this as well, and delete this as well. Okay, and I'll just move this to the side so that we have a good space. Okay, now let's take an example for class B IP address. So we'll just write down the example. Let's say 172.16.0.0. This is a class B IP address, and I'll say that I require how many hosts. Now the raw capacity 65,000, so that many hosts it can have. Now let's take an example. Let's say 5,000 hosts. Okay, the one we were talking about earlier. So 5,000 hosts. The first thing is to calculate. So step number 1, calculate bits of your requirement. So 5,000. How many bits? 5,000 will be somewhere over here. So this is 5,000, and just calculate 1 2 3 4 5 6 7 8 9 10 11 12 13. So 5,000 will be needing 13 bits. Okay, second, write the old subnet and the new subnet. So I'll just write the old one over here. So it will be 16. It's showing 16 bits. So 1 2 3 4, so 16 ones. Okay, and 16 zeros. Okay, in the new subnet, see, the new subnet, I cannot touch 16 bits, so I'll just write them as it is. Okay, now for my 5,000, I require 13 bits. So I'll just start writing from here, because you always start writing the host from the right and you move towards the left. Okay, so 8, then 9, 10, 11, 12, 13. That's it. The remaining 3 I'll give it to network, because I don't want to use them. Now the third step, now all of you might have gotten an idea about what we have to do in the third step. We have to calculate the block size. I'll just write the block. Now what is the block? Now block size is calculated per octet. So this is in the octet. Okay, let's take a different pen. So in this octet, if you see, the transition happens over here, and since you do it within the octet, what is the value? This is 0, 1, 2, 3, 4, 5. So this is 5. So 2 raised to 5. Now what is 2 raised to 5? 2 raised to 5 is nothing but 32. So my block size is 32. Now my fourth step, I have to write my new networks. So I'll just start from 172.16.0.0. What will be my next network? Now see, concentrate over here. Where did I get the block size? I got the block size in the third octet. So here I'll just write it. The block size is in the third octet, and I have to add, sorry for this mistake, it's octet, sorry. Okay, so 172.16.0.0, I have to add 32 in the third octet. So I'll just add this as 32.0. Then my next network will be 172.16.64.0 and so on. It will go till the time I don't end up using the entire IP range. Now where will this end? This will end at 172.16.31.255, because if I add 1 over here, this will become 32.0. This will end at 172.16.63.255. This will end at 172.16.95.255 and so on. So if you just take down a pen and a paper, and if you write down the last network which I will achieve over here is 224.0, and this will end at 172.16.255.255, and this will end my network scope as well. Like, now if I add anything, I'll be just moving down to 172.17.0.0, which I don't really have the permission to subnet, because I had only this network. So within this network, I have to do whatever I can. Now the next thing is to verify your calculation. Now as I showed you in the steps, you have to find out the number of networks and you have to find out the number of hosts. Now network is not important because our requirement was majorly host, right? But still we'll calculate the network. So where did the subnetting happen? The subnetting happened over here. So I'll just focus, subnetting happened in these two octets, because these were the two variable octets which I had. These were fixed. So I'll just mark it over there. So I'll just say these are the fixed octets. Okay, and this is the variable octet, because that's where the hosts were residing. So in the variable octet, find out how many network bits you have and how many host bits you have. So I have 3 network bits and I have 13 host bits. If I just put it into the formula, so 2 raised to 3 gives me 8 networks. So I have 8 networks over here. And if I put the host bits into the formula, so 2 raised to 13 minus 2, that will give up 8190 hosts per network. Right. Now the raw capacity of class B is how much? 65,534. So it will be we'll just put minus 2 over there. So 534. Now if I would have given someone an entire range to use, and if that person wanted only 5,000 addresses, so how many addresses would have been wasted? Around 60,534 addresses would have been wasted. If I am giving him 8190 hosts, so even if he just wants 5,000, I am ending up wasting only 3190 addresses, and that's affordable. Rather than wasting 60,000 addresses, I am now wasting only 3,190 addresses, but I am using the class addresses more efficiently. If someone has a similar requirement, like somewhere around 5,000 or 6,000 or 7,000 or 8,000, I can give them. So I have 8 such networks which can now accommodate up to 8190 host. So if someone else comes in with the same requirement, the ISP could sell them these networks as well. So now instead of one person using and wasting a lot of addresses, now I have 8 people who can use and they can waste a lesser number of addresses. That's what subnetting does. Subnetting is done so that you have efficient utilization of your IP addresses. Well, so I hope this has been informative. You can comment down your thoughts below. And what I have done is, in the description box below, you will find a link which will be a notepad file in which I have shown examples about class C addresses, class B addresses, and class A addresses as well. So for your practice, I am putting that file online. So you can just click on the link in the description box below and download that notepad file as well. I hope you enjoyed watching this video. Do like the video if you enjoyed watching this. Share it with your friends. Subscribe to our channel, because we come up with videos every Monday and Friday about different topics in networking. So this was about subnetting. In the next video, we're going to discuss about variable length subnet mask. So this was a fixed length subnet mask. just to highlight one thing over here, what is fixed length? So fixed length is once you calculate the block size, you continue breaking your network with the same block size till the time you don't reach the end. In variable length, the block size keeps on changing, and since the block size keeps on changing, your networks also keep on changing. And before we sign off, just finish this last step, how the new networks will look like. 172.16.0.0 slash how much, 172.16.32.0 slash how much. How much? Just calculate the number of ones. So it will be 8 plus 8, 16 plus 3, 19. So it will be slash 19. So all the networks which you now write will be slash 19 networks. Instead of a slash 16 network which had 65,000 hosts, now you have 8 slash 19 networks which have a capacity of 8,190 hosts. So thank you for watching, guys. Take care. I'll see you in the next video where I'll be discussing about variable length subnet mask. Till that time, stay tuned. Take care. Bye-bye.